Hi dear students. So in the last class we have discussed about the acceleration. Acceleration is actually how faster the velocity changes with the time, or we can say the rate of change of velocity with respect to time, dv by dt, or delta v by delta t. In another way, if you are saying that is v2 minus v1 divided by t2 minus t1, where v2 is the final velocity, v1 is the initial velocity, t2 is the time which we are having the velocity v2, and t1 is the time, the initial time. At t1 we are having the velocity v1. So regarding the acceleration we have discussed in the last class. Now let us come to few graphs. Okay, a few graphs. For all the graphs, the objects, or in all the graphs, the object is moving with a constant acceleration. Okay, so you can see it is a v-t graph, velocity time graph is given, and all the graphs are linear lines. That means whenever the time increases, equally for equal intervals of time, equal velocity or the interval of the velocity is also equal, isn't it? Velocity is increasing or decreasing with equal intervals of time. So that means such kind of motions are known as the motion with a constant acceleration, or the acceleration value will be a constant. So suppose come to the first graph A, you can see that when time increases, the velocity is also increasing. The initial velocity is v0 and the final velocity is v. So we can say it is in the positive x direction. The motion is in positive x direction, and velocity is also increasing. Okay, so velocity increasing and motion is in positive x direction. If you are coming to the second graph, okay, the graph B, you can see that when the time increases, the velocity is decreasing, isn't it? v0 is above and v is below. As the time increases, the velocity is decreasing. Okay, but you can see that the motion is in positive x direction. The motion is in positive x direction. But the velocity is decreasing. Come to the third graph, C. Here you can see when time increases, the magnitude of velocity is increasing, but the direction of motion is negative. Okay, time increases, as the time increases, magnitude increasing, but if you are coming to the value is decreasing, and the direction of motion is also in negative direction, negative x direction. So we can say the object is moving in the negative direction with a negative acceleration. In the above cases, the first one was with a positive acceleration, second one was with a negative acceleration, third one with a negative acceleration, and the fourth one is also negative acceleration. But you can see it is crossing the t2 axis. That means from v0 to t1, okay, the direction was positive direction and velocity was decreasing. But t1 to consider this point as O, okay, the direction is changing. Okay, it is in the opposite direction, it is the negative x direction, but there also the velocity is decreasing with a negative acceleration. But after a time t1, the direction is changing, the direction of motion is changing. In the opposite direction, the movement is happening, but the velocity is decreasing gradually or uniformly. Okay, so these are the major concepts regarding that graphical representation. So just do one thing, in the page number 46 the explanations are given. You just go through that one once. Okay, now let us come to the next one, that is the area under the VT velocity time graph equals displacement of the object over a given time interval. Okay, here one graph is given where the velocity value is a constant. That means when time increases the velocity remain constant, and we can say that is a uniform motion as the velocity is constant. Equal displacement is equal intervals of displacement is happening for equal intervals of time. Now you know that if the displacement value d is given and the time taken is given, so d by t will be is equal to the velocity. Okay, suppose here in this case the velocity is given as u, so we are taking the u as the velocity here. So d by t will be is equal to u. So if you want to find the d value, d will be is equal to t into u. Okay, so d is equal to t into u. Now here the graph is a straight line which is parallel to x-axis. So if you want to find the area under the graph, you know that it's a rectangle, so the length into breadth will be the area of this rectangle or area which is under the graph. So here 0 to t into 0 to u, that is the breadth, and length it is 0 to t is the length and the breadth it is u, so t into u. Okay, t into u. So you can see, you can compare both the area and the displacement equation, both are equal, isn't it? ut, tu and tu. Displacement is tu, the area under the graph it is t into u. So you can say the area under the graph, which graph? The velocity time graph, gives us the value of the displacement occurred. So the explanation is given below. The VT curve is a straight line parallel to the time axis. That means the velocity is a constant value. Even whenever the time increases, there is no change in the velocity. Velocity is constant and the motion is a uniform one. The area under it between t equal to 0 and t equal to t is the area of the rectangle of the height u and base t. Therefore the area of the rectangle it is u into t ut. If the velocity and time values are given, then u into t is the displacement, so that is equal to the area under the graph. So the statement is proven and the statement is true. So what's the statement? Area under VT graph equals the displacement of the object over a given time interval t, isn't it? So that's regarding the same way the area under the acceleration time graphs gives you the velocity value. Area under the acceleration time graphs gives you the velocity value. Okay, so that we will discuss later. Now come to physically the VT, velocity time graph, acceleration time graph and position time graphs should be continuous and the curve should be smooth one. If you are observing in your textbook, page number 4.5, figure number 3.8, you can see that in some cases sharp decreasing and sharp edges are there in the graph, isn't it? For the figure number 3.8, just for the time t is equal to 10 seconds, you can see a sharp edge over there, isn't it? So actually such kind of, if we are considering the motion practically, that is not possible. That means if a body is moving with a velocity of 40 meter per second, consider, it cannot at a point, it cannot move to 20 meter per second. So directly it is not possible to move from 40 meter to 20. In between the 30 will come as well. The all other values in between 40 and 20 will be there. So the graph cannot be discrete graph cannot be possible, or with a sharp edges the graph cannot be possible. Then the graph should be smooth lines, because if it is 40, it should reach it should go through the 38, 35, 30, then 28, 20, 25, 22, then 20. Are you getting or not? Means the graph should be a continuous one for the position time graph, velocity time graph, and graph and acceleration time graph. If you are considering the values in a physical way or in a practical way. Okay. So you should remember this one. The graph should be smooth one and continuous. Okay, now come to the kinematic equations for uniformly accelerated motion. We will be considering only uniformly accelerated motion in a straight line. Okay, so regarding the kinematic equation, there are three major equations and that are very important, and this portion is very important. So come to the first kinematic equation, V is equal to V0 plus AT. So regarding this equation, you should remember that acceleration value A is equal to delta V by delta T. This is actually the explanation or the derivation for this equation. So listen carefully. So A is equal to delta V by delta T, which is equal to, suppose initial velocity, so final velocity was V and the initial velocity was V0, divided by the delta T is T2 minus T1. So T2 minus T1 we will be considering as T, okay, small t, T2 minus T1, that is the time interval. Suppose the initial time was 5 seconds and the final time was 10 seconds, then the time interval it is 10 minus 5 seconds. Okay, that 5 seconds is this T. Getting or not? So time interval is taken as T. Then you can see V minus V0 is equal to T into A. That means implies the final velocity V is equal to V0 plus A T. Okay, so final velocity V will be is equal to V0 plus acceleration into time. I think it is clear. And maybe in the examination the chances are there, means maybe the derivation or some you have to find some solution for the mathematical solutions. So mathematical problems will be there. With the help of these equations you can find out the values, unknown values. Maybe a V0 value given and V value given and time is also given. You have to find out the value of acceleration. Then it will be A is equal to V minus V0 by T. Suppose acceleration V and V0 values are given. Time period you have to find, if suppose, then T will be is equal to V minus V0 divided by A. In such a way you have to arrange the equation and find the values. Okay, now let us come to the second kinematic equation, that is X, the displacement occurred, is equal to V0 T plus half AT square. V0 T plus half AT square. So we have already here a graph is given, that is a VT, velocity time graph. You know that if a velocity time graph is given, then the displacement should be equal to the area under the graph. So here the area under the graph is divided into two as a square or a rectangle and a triangle. Okay, So we have to just add up these areas of this triangle and rectangle, and then you will get the displacement. So simply x is equal to half into v minus v0. Half into v minus v0 is the area under that triangle, or area of that triangle A C B, where v minus v0 is the height, v is the final velocity, v0 is the initial velocity. Okay, so v minus v0 is the height into t. It is the base length of the triangle. So you know that equation for finding the area of the triangle. So you got the area of the triangle. Now you have to add up the area of the rectangle, that is v0 into t. v0 into t. v0 is the breadth and t is the length. Here t is the base length for the triangle, and v minus v0 is the height of the triangle. So as we know, but v minus v0, from the previous equation you know that v minus v0 is equal to at. So instead of this v minus v0, you are substituting the value as at. So at into t, isn't it? At into t will be there, that is at square plus v0t. So x will be is equal to v0t plus half at square. Or in other words, we can say equation 3.7 can also be written as v plus v0 divided by 2 into t. X is equal to v plus v0 by 2 into t. Means v minus half of v minus v0 t plus v0 t is there. If you are adding up that, the answer will be v plus v0 divided by 2 into t. For a constant, if the value of the acceleration is a constant, then v plus v0 divided by 2 is equal to the average velocity for a constant acceleration. So x is equal to v bar into t. This is the initial equation actually. V bar is equal to x by t, or delta x by delta t. Okay. So for obtaining this equation, okay, for obtaining this one, you have to just open the bracket over here, this one, half of v minus v0 into t, and you just add the values, then you will obtain this value. Just try that one. Okay, now come to the third equation, that is x is equal to v bar into t. For v bar, we have already discussed for the constant acceleration of a object. If the object is moving with a constant acceleration, the v bar value will be is equal to v plus v0 divided by 2. As well, from the first kinematic equation, v minus v0 is equal to at. So v minus v0 by a will be is equal to t. So v bar and t values we have substituted. This is the value of v bar and this is the value of t. Now you have to just open up the brackets and you will obtain the value as v square minus v0 square divided by 2a. Okay, so x is equal to v square minus v0 square divided by 2a. V plus v0 into v minus v0, a plus b into a minus b, which is equal to a square minus b square. That is over here, and 2 into a divided by, that means 2a. Now you have to just means you know that x is equal to, you obtain the equation as x is equal to v square minus v0 square by 2a. Just cross multiplying, then v square minus v0 square will be is equal to 2ax. That means v square will be is equal to v0 square plus 2ax. So these are the major kinematic equations, and the application level questions we will discuss in the class next or in the coming lecture. So just go through the textbook and thoroughly, okay, just go through the textbook and make this concept very clear. These are some important portions. Okay, from this chapter many questions can be asked from this portion, so go through this one. Okay then, thank you.